In this video, we'll go over a standpipe bag, the components, and how to use them on a standpipe valve. Start with the 2.5-inch pressure gauge. There's also the 45-degree elbow to help remove kinks, and one of two different gate valves that you may see in the rank. Here's Captain Klug to show you how.
All right, we're going to talk about our standpipe kit and how to hook up to a standpipe using the tools we have inside. So we'll be carrying some type of elbow. This came straight out of our pump, but we're going to use this today, and we're going to hook this up to our standpipe. Obviously, we need to remove the cap. Sometimes these are going to be stuck on. We have spanner wrenches available in the bag that we can take these off with. So we're going to remove our cap. As we were taught in the academy, 3 points of contact against the wall so it doesn't get kicked down. Next, in this case, we're going to use an elbow, and this is going to help prevent our hose from kinking eventually once we hook up. So we hook this on to our outlet. And then next comes our gate and gauge. These you may choose in your bag to connect these together right off the bat, or they might be in two pieces. Either way, our gate is going to connect next. Check for your gasket. And we'll go connect that to our elbow. Ensure that this is closed in the closed position. And now we have our gauge ready to go. This also has a swivel, 30-degree swivel on it. So now we're going to spanner tight this, all our connections. Spanner tight. And spanner tight. All right, we're ready to go. Next step is to open our wheel. In this case, we're able to turn this, but understand that standpipe systems, the minute they're built, they're in a state of decay. So there's a good chance that these things will we won't be able to open them by our hand because they get rusted shut. So we can take our monkey wrench, we can use that to turn it, just like that. We also have our other spanner here. What's the word I'm looking for, Dave?
Knox.
Our Knox spanner that we can use to help open that wheel if it's stuck. So we're going to open this wheel all the way. 100% open. Stops. I'm going to quarter turn it back in case someone else comes and they need to check to make sure they know it's open. So now, I'm going to move my bag out of the way. We're going to open this gate and we need to flush the system. These systems are notorious for having tons of debris, sediment, Cheeto wrappers, whatever it may be. We're going to open this up. Nice clear water coming out, so we're going to call that good. From this point, we're going to hook up our female coupling to the outlet. The nozzle firefighters, when they're ready to call for water, we'll give them water, and then we will set our pressure. The way we do that is with this gate valve, okay? Just like if we're down at the pump, we're going to figure out what the appropriate pressure is. We'll have a cheat sheet available in our standpipe kit so that we can, under pressure, we can know what that residual pressure should be set at.
Let's look at the Knox locking caps and key wrenches. So as a driver operator assigned to water supply for a standpipe or a high-rise, the tools that you're going to need are one of the new Knox spanners. You have these issued to the fire engines. Good idea to keep this in your standpipe kit. You'll notice that it's a wedge, has a gas key. It's going to have a 2.5-inch spanner. It has the pins that hook up to the Knox locking caps that are being mandatory by the city now, and it also has the key portion here, and that key portion is going to fit into the keyhole. That keyhole sometimes is going to have a rubber piece in it that's going to be removed. You can sometimes use this wedge portion to pull it out, or you might need to grab some sort of a sharp object like a knife to pull the rubber out when that happens, when you find that on the FTC. Cool, that should have been the word standpipe. This tool is super valuable, so when an engineer enters the building and accesses a standpipe or is accessible from the outside, they recognize that they have this. This piece is locked. You cannot turn it until the FDC key unlocks it. So you spin it to the left. You'll see it says Knox lock over here is tight, over here is loosen. So lefty loosey, give it about 5 turns. When you see that the outside starts to spin, you now know that you can start to remove the cap, just like you would a normal male plug. It comes out, you see internal components. This piece just stays on the ground, keep it out of the way. Now you have access to the threads, gasket, and check your swivel. Make the 2.5 connection to the furthest out inlet. Now we switch over to using the 2.5-inch spanner wrench, which has this cutout for the lug rocker, which is standard. Just holding it on the male side, spinning it on the female side. That's spanner tight. We can charge this because there's a clapper, or we can wait until both lines are connected before charging. We're going to talk about some connections on the standpipe riser. We're going to start with the simple version. So this is going to be a full flow valve. You notice that it's small from top to bottom. When you remove the cap, one of the ways you can identify a full flow valve is the presence of threads on the yoke. So you can see in there the presence of threads. And as I open the wheel, you'll notice that I can access 100% of the 2.5-inch opening. It's going to give us full flow. Good. The next standpipe connection that we're going to talk about is the PRD, pressure restricting device. You'll notice when you compare it, it has a little grenade type pin and a collar here. And what that's going to do, it's going to restrict how much of the opening I can access. I can't turn the hand wheel anymore because this pin system is locking it out. The restriction only gives me this much flow, intended to reduce the amount of pressure I get in the line. Now, how would I adjust that? If I close the valve a little bit, it gives me some slack, I can put a tool in or use my hand to pull this pin out. Once the pin is out, it's going to allow the collar to rise above and allow me to get the full flow that I need and no longer restrict my pressure. That's the PRD. The next device we're going to talk about is the ones you'll find in high rises. High rises need to restrict the pressure down to 100 pounds. And this is a PRV, pressure reducing valve, also known as a pressure regulating valve. When I look at it, you can see that it's larger in size compared to the others. Much larger device. This has a pressure restricting valve, pressure reducing valve inside. In order to adjust it, we'll need to uncap it. Check your threads. Make sure you have no obstructions. Make your connections. In the high-rise kit, we're going to add a elbow. A gate. The gauge. And our hose. It looks funny because it's not lined up quite correctly on this thing. Give these a quick spanner tight. At this point in time, the connection's made. The firefighter on the hand line will call for water and flow will be established. The line must be open and flowing in order to adjust the PRV. So they open the line. The valve must be all the way open and water flow established. We'll be using the gauge here to set the residual pressure. The point of the video is to show you that the rod, steel rod, not aluminum, is going to go in the slot here. That slot's going to line up with this hole underneath. That's how we adjust the pressure. If the cap is in the way, it's no problem. When you read it, it says increase pressure, turn cylinder nut to the left. So I'm going to increase pressure while I keep an eye on the gauge. It's going to restrict. I pull it out, I push it over again, and I continue the process until the pressure matches what I want. This is the Giacomini's Italian brand. It's very large PRV. You'll notice a large hand wheel, very tall device. That pressure relief device is inside. In order to adjust this, the valve has to be, again, fully open. Once it's fully open, you'll recognize what you recognize over here on the L-cart is the place to insert the rod. When you insert the rod, you need to turn it to give it more pressure. Again, utilizing your pressure gauge to find that flow. Cool. Cool, now we're gonna look at the Zern 3000, very common in the city. You'll notice that it doesn't have a rod adjustment area. It doesn't have a pin, so the internal components lie underneath the bonnet. So that's where the large 18-inch pipe wrench comes into play. And then we're going to use the socket. So the first thing we need to do is establish flow by opening the valve. At any time any of the hand wheels are difficult to open, two devices will help you unlock those. The Knox box version of a spanner can be inserted into the hand wheel and used as leverage to open it. Works out really well. Or if you've already got your pipe wrench out, the same device can help you open the wheel when you have tough and sticky wheels. Once the valve is all the way open and you're flowing water to your firefighter who's requesting more pressure, now we want to remove the bonnet. The 18-inch pipe wrench is going to go around the bonnet and turn it. So open it large and wide and remove the bonnet. And the pipe wrench can go back in the bag. When you loosen the bonnet, it allows the wheel to come off. This is when you're going to see the adjusting knob that's inside. This is a 1 1/16 inch deep socket. You stick it on top and it's a lefty loosey, righty tighty. So I want to increase the pressure. No different. I loosen up the valve. So as I loosen, I'm looking for that residual pressure to operate the hand line in place. Again, water must be flowing to make these adjustments or it'll work against you.